What is a universal set? By definition, a universal set is the collection of all objects in a particular context or theory. The objects of such a collection are called elements. Speaking of context, we can speak of a set that contains all the natural numbers, the set of all even numbers, odd numbers, or the set of the natural numbers from 100 and less. Since by definition, a universal set is a set that contains all the elements in a given context, all of the given sets that are written on the screen can be universal. For example, if we take the set of natural numbers n as our universal set, then all the other sets that are written on the screen are subsets of such a universal set. This is because set n contains all the elements that can be found on the other sets. Again, if we take set A as our universal set, then all other sets that can be found elsewhere and contain at least one or all of the elements of natural numbers from 1 to 100 automatically become a subset of such a universal set. Or stating it the other way, the universal set associated with sets A subscript 0, set B, set C, and set G is the universal set A, which contains all the elements found in these sets. In general, the definition of a universal set, the superset, and the set itself are somehow related. This gives confusion as to what is a set, a universal set, and a superset. For example, if we have set A with elements 1, 2, and 3, then the subsets of set A are as follows. So we can say that the universal set of all of these subsets is set A itself, because set A contains all the elements that are found in each of these subsets. Furthermore, the superset of all of these subsets is A itself because of the same reason that it also contains all the elements of the subsets. So now how we can differentiate a superset from a universal set or a universal set from a set itself? Let's go back to the subsets of set A as given. If we remove all the subsets of set A containing 1, then the superset of the remaining subsets is still set A. But set A is no longer the universal set of the remaining subsets. If we denote the remaining subset as set B, then B only contains 2 and 3 as its elements. Now set B becomes the universal set of the remaining subsets of A. Because set B contains all the elements of the remaining subsets of A, while set A contains one extra element that is not an element of the remaining subsets. Therefore, the universal set must contain exactly all the elements of the given sets. On the other hand, the superset is a specific terminology used to denote the set from where the subsets were derived. The subset-superset relationship can be interpreted as the father and son relationship. If between two people, if one is the father, then automatically the other one is the son. If the other is the son, then automatically the other is the father. This relationship is particularly helpful if two sets A and B are equal sets. If you assume that set A is the subset, then automatically set B becomes the superset of set A or vice versa. Another controversy arises because the union of the given sets is equal to the universal set. So does this mean that the union of the given sets is also the universal set? Just let us know and leave your comments below in the comment section. At this point, it is important to note that many of the set theories do not allow the existence of the universal set for reasons that we may deal on another video. Now let us ask ourselves, what is a set? The word set is a general term that is used to refer to different types of sets such as subsets, supersets, universal sets, etc. All of these sets are the same in that all of them are a collection of objects or elements. But they differ from one another depending on the circumstances in which they are applied relative to other sets. I hope this video helps you understand the concept of the universal set, superset, and set in general.